Hello Senior 2, how are you all? Today I talk about the total internal reflection. Occurs when a light ray travels from an optical denser medium such as water to an optical less dense like air. As we know from the previous lessons, if the light ray fell perpendicularly on the surface, so the angle of incidence equals 0. So the light ray enters into the optical ray medium without any refraction. Number 2. If the angle of the incidence increases to be greater than 1, so the light will be refracted away from the normal. Number 3. By increasing the angle of incidence, the angle of refraction will be increased gradually, Snell's law, and theta equal n sine phi. Number 4. At a definite angle of incidence that known as critical angle, the angle of refraction will be equal 90, and the light ray refracts tangentially to the boundary surface. Last one, when the angle of incidence is become greater than the critical angle, the light reflects back in the optical denser medium, and the angle of incidence equals the angle of refraction. The relation between the critical angle and the refractive index of the medium. From the Snell's law, sine phi c equal n2 over n1 equal n from the first medium to the second medium. If the medium is R and if isn't R. If the medium is R and of R it's given 1, so n2 equal 1, so n1 equal n, so n sine phi c equal 1. So sine phi c equal 1 over n. If the medium isn't R, so n1 sine phi c equal n2, sine phi c equal n2 divided n1 equal sine phi c1 divided sine phi c2. Applications of the total internal reflection, like number 1, optical fiber or fiber optics. Its structure is like a tube of transparent elastic material which can be painted while containing light and can be made of bundle of fibers, and it's bending on total internal reflection. It's used to transferring light to parts that hard to reach and transmitting light in non-straight path without losing a large amount of light intensity. And it's used in medical examination and diagnosis for some diseases, and in the operation using laser beam. And recently it's using for communication, as light can carry millions of electric signals. Number 2, for the application of total internal reflection, reflecting prism. It's a triangle glass used whose angles are 45, 45 and 90, and the refractive index equal 1.5. The idea of working changing the path of light ray by 90 degrees. When a light ray falls normally on one of the right angled faces of the prism, it passes straight and falls on the opposite side, and the angle of incidence equals the angle of refraction 45, 45, so the angle between them will be 90. Number 2, changing the path of light by 180 degrees. When a light ray falls normally on the opposite face to the right angle, it passes straight and falls on one of the right angle face by angle 45. The light will be reflected totally by 45. The reflected angle on the other right angled face will be reflected by 45, so the angle between them will be 108. So we can use changing the path of the prism by 90 or 180, and it's used in some optical instruments such as periscope and submarines. The last one is mirage. During hot days, the road seems covered with water, and the palms seems as inverted pictures, and this phenomena is called mirage.